So welcome to this edition of Seen Solved, presented by Hubbard-Hall. I'm Tim Pennington, editor of Finishing and Coating. Today we're joined by Jason Potts from Hubbard-Hall, and today we have a topic of Electroless Nickel, and Jason's going to talk about 5 ways to extend bath life, and with that of EN. And Jason, I'm sure there's more than 5 ways, but this is probably going to be the top 5 that people can remember. I know they usually can't remember more than 5 or 3, something like that, but thanks for joining us today.
Thanks for having me.
I'm Tim Pennington, and you're listening to Seen Solved, brought to you by Hubbard-Hall. Better results, less chemistry. Like I said, you're another new person to Hubbard-Hall. I know you've been in the industry for many years, many years. Where did you get your start?
So I've been in the industry for 28 years.
28, wow.
Yeah, 28. I started at a young age at a place called, it's HM Quackenbush in upstate New York. Mm-hmm. I started there in production and moved my way up through into quality, waste treatment, and eventually at the end I was a general manager, and one day we went out of business. It was just like that. It was unfortunate. While I was there, I was fortunate enough to develop a class at the local college, and a cool fact is I'm on a handout from the local college of sitting in front of an old X-ray 1010 machine, wow. Which are very old X-rays. So that's where I started. From there, so I spent 12 years there, so on the applicator side, and 16 on the manufacturing side.
Gotcha. And so now with Hubbard-Hall, what's your specialty there? What are you an expert at?
So my position is product manager. I have experience in all metal finishing processes. I would say my most experience has been Electroless Nickel, and I think that's what we're here to talk about today.
Yes, definitely. So again, the topic was ways to extend bath life. So let's start with the very first premises. Why are the reasons that shops need to dump their bath? What's wrong with it? What's happening with it? Why are they dumping the bath?
So what happens with electrolytic? So let's look at the difference between electroless nickel and electrolytic. So the easiest way to explain it, you take an electrolytic bath, whether it be nickel, copper, chrome, those baths will last 20, 30, 40, 50 years. Those baths don't really generate any type of byproduct. With electroless nickel, you make it up. It makes up at 6 grams per liter nickel, and you make up with 30 grams per liter of hypo. For every metal turn, and a metal turn is the add back, or let's just say a metal turn is, you'll produce 30 grams per liter of ortho for every metal turn. So on a new bath, you have 6 grams per liter of nickel, 30 grams per liter of hypo, and at 1 turn, you have 30 grams per liter of ortho. At a 10 turn bath, you still have the same 6 grams per liter of nickel, 30 grams per liter of hypo, and 300 grams per liter of this orthophosphate that forms. So what happens to the bath, plus you have sulfate in there. So what happens to the bath, it becomes viscous, it slows down, more staining, cracking, pitting, everything that can be detrimental to a finished part, especially in salt spray.
Right. So you said it slows down. So what makes a bath slow down? And I guess that's, and my premise question to that is, can they catch that the bath is slowing down, or until they just see some parts that are not looking right? But do they catch that? And then what's making it slow down?
So yeah, you can catch it. I mean, if you're a typical EN bath, if you're doing standard mid-phos, you're going to go 8 metal turns. You can predict your 8 metal turns based on the square footage you're running. You're going to know that throughout that time, it's going to slow down. So what makes it slow down? There's 4 parameters that's going to keep the bath at the speed that you want to keep it at. You have temperature, pH, your nickel, and your hypo concentration. Mm-hmm. You can keep those all within 90 to 100%. But as the bath ages, you're going to have the contamination. That contamination, it slows the deposit down. And there's also, on top of that, you can have contaminants like nitrates, zinc, which we may talk about, chrome, which is detrimental to the bath, and other metals. And stabilizers, some metal stabilizers can slow it down.
Right. So like I said, you've got a lot of things going on. To me, it sounds like if people aren't staying on top of the bath, if they're not really documenting and doing some proper maintenance, they're going to have the issues, some of the bigger issues that you've talked about of just having to dump it more often, right?
Oh, absolutely. EN, EN takes a lot more control, the control of an electroless nickel bath, because you have no electricity, hence EN, electroless nickel. So your electricity is your hypo. So if you don't have the right amount of hypo, you don't have the right amount of electricity, and you're going to get slow plating rate, or you might change your parameters in the bath enough to where you can change the percent phos in the deposit and have failures, because you're gonna certify whether you want to plate 9% phosphorus or 11% phosphorus. You need to be within that range. So without controls, you're not going to have that. With a standard electrolytic bath, you're going to put the part in, you're going to look at the square footage, you're going to put your ASF where you need to be, and go for a target thickness. Pretty much your additions are already, they have brightener feeders. With Electroless Nickel, your add backs has all your goodies in it, I would say.
Mm-hmm. Right. Let's add another conundrum to it. I know aluminum actually causes more problems than EN baths, right? So what is the different about processing aluminum, and why is that caused? What's the driver on that of having people having to dump baths prematurely?
So aluminum, it loves oxygen, and when it does, what happens is it oxidizes. Unlike steel, you could go through a standard soak clean, electric clean, an acid activator, and right into the EN. With aluminum, you're going to go through a soak clean and etch, and then you're going to deox, and then you're going to zincate. What the zincate does is it protects the aluminum from oxidizing. Oxidizing causes blisters. So when the part goes into the bath, it has a very thin layer of zinc onto it. And into the bath it goes, it strips that zinc off. It immediately starts to plate electroless nickel, which stops the oxidation from forming. As the bath ages, your bath ages, now you're putting zinc in there. So zinc, number one, that's a contaminant. Bath ages, bath is going to slow down as it ages. So your activation slows down. And as the bath ages, your total acidity also increases. It's not going to be because of low pH, it's total acidity. So what happens is you take an aluminum part, you start going in, say you're at 4 metal turns, you put the part in, the zincate strips at such a fast rate, but the initiation slows down on a nickel, and it leaves that minute second for oxidation to form, and you get blisters. So therefore, typically on an aluminum bath, you go 4 metal turns. You can do an alkaline strike ahead of it, to where the zinc is mainly staying into the rinses beforehand after you strip, and you can get some more life out of the bath, but it has a finite life. It's only going to last between 4 to 6 metal turns with aluminum.
Wow. Okay. Wow. There you go. It's funny, you were talking about contaminants earlier. What should platers look upstream for that could possibly be causing problems that they're bringing into the tanks? I guess any of those processes that are happening. You mentioned a lot of things steps that are going on there, but what are some things that you should be looking at that could cause problems?
Well, what most shops typically struggle with is water. All right, so you want good rinse water, and if you don't have good rinse water, whatever you're pouring out in a soak clean is going to go into the rinses, or the electric clean, or the acid. It'll go into the rinses. In those rinses, you could have organics, you could have metals, you could have oils. Any of those can be contaminants, especially when you get into any of the stabilizing metals. You get a stabilizing metal that gets into a rinse, it gets into an EM bath, overstabilizes it, then you have edge pullback, you have blisters, array of things that you just don't want. I mean, so you really want to make sure your rinses beforehand are as clean as you could possibly get from what your waste treatment can allow you to handle. You don't want to overflow, obviously, or go after your waste treatment at that point and have issues there. Right.
Yeah, I was going to say, it's something I think a lot of people maybe don't often look. They're just looking at the bath, right, sometimes, and wondering what it is, instead of really going through the process and seeing, kind of a cause and effect of what's happening, right?
It's always the bath.
Right, exactly. It's always that, and it usually never is.
It never is usually.
Right, yeah. I was going to say, and you mentioned particles in the tank that can become plating sites, I guess, plate out the tank. Explain that to us, and what can shops do to sort of minimize chances of that happening?
Yeah, so with electroless nickel particles, it's a common problem, especially when you get into the high build areas. When I say high build, you're talking 2,000s to 10,000s, and with particles, they can settle on a shelf area. So the top of a part, some very minute particles. The particles could come from something as simple as a sandblasting operation being, just 20 feet away, which is bad, or a fork truck going by and dust coming up, and those particles go into the bath, and those particles will actually co-deposit. A lot of times the ceiling, they have hoist systems up, and it's bouncing, and it's a plating shop. Plating shops are rusty. It's hard to stop that. So you get particles in there, and they'll rest on top of the part. It's typically on a shelf area, and you can cause blisters, you can cause roughness, all kinds of like what they call like snowflake or haze on top of parts.
Right.
The bath is designed, it's chelated and it's wetted enough to kind of like handle those particles. And there's other things you can do too, is like a work bar agitator. You can add a little more air, but you got to be careful with air because that's a stabilizer too. You could do eductors and try to push solution around. So even though there's particles that are definitely going to come into the bath, there's things you can do to fix that. And a lot of it would be just filtration. You need to filtrate probably 10 to 20 times per hour in 1 micron filtration. Not many shops do 1 micron. And they use bag filters too, as opposed to cartridge filters. That's the better filtration for roughness or for particles.
Right. Yeah, because it definitely can cause a problem with that. One other issue. Let's talk about salt spray testing, because I know it's called out in many specs, right? But I understand that EN has kind of a difficult time achieving things. Achieving the requirements consistently. What can be causing this, and what do platers have to kind of do to make sure that they're meeting the specification with that?
Yeah, so you have another hour because we could talk about salt spray a lot.
Right.
That's near and dear to me. Salt spray has been an issue for years. The problem with salt spray, when you talk about salt spray, you're taking typically a 4x6 Q panel. You're plating it in a perfect environment, whether it be a lab, perfect loading, perfect cleaning. Everything is right where it should be. You go in the salt spray chamber and you pass sometimes.
Right.
You could do it 10 minutes later thinking you're doing the same thing, and it's going to fail.
Right.
And then you throw this in there. You have customer parts that don't even look like a panel. And they want 1,000 hours or 100 hours, whatever they might be. It doesn't even look like the panel that you're trying to pass. So with salt spray, it comes down, again, we'll go back to everybody says, well, it's the bath. It's probably not the bath. It's probably the way you're operating the bath and what you're doing beforehand. A lot of times it's cleaning. Cleaning is critical. Cleaning of a panel or parts is very critical because you have to get the soils and oils off of it. You have to make sure it's not etched. You don't want to etch it. Your panels themselves, you can buy different panels that have different surfaces on them that can cause, failures. And then after that, you have the bath. You have the bath. If the bath is brand new, you don't want to run a panel in a brand new bath. You have to break it in. You want to be at a quarter metal turn. You want to have the proper filtration. You don't want to have the particles. Your post-treatment, your post-treatment has to have good clean rinses. So you can have, and then when I say all this has to be like this, a perfect, or loading. Loading's another example. Mm-hmm. Under loading, you're going to have heavy metal, or metals, I should say, metal stabilizers that will attach to edges of the part or places that's considered that would be a low current density area if there was electricity. And in that area, you're going to fail in a salt spray chamber. So to pass salt spray, you really just have to think about, in my opinion, what you're doing upstream and control that bath. Do everything as best you can upstream, the cleaning, the rinsing, and then make sure the bath is right at where typically you want to run it about 90%. And there's different salt sprays too. Obviously, mid-phos they're typically shooting for 100 hours. High-phos is 1,000 hours.
Right.
So, like I said, you can do everything possible to make sure it's right, and you're still going to have issues. It's just the way it is.
This way it is. Always going to be a battle with those.
It's a battle.
Right. Well, like you said, and it's why it's the people that could do EN right do it right. I mean, it's very technical, and you have to pay attention. Not just anybody can do it. I mean, it's something where it takes training and it takes expertise and it takes the right chemistry and the right setup and really the know-how, like you said, of looking upstream and making sure that you're not hurting the bath with things that you may be putting into it. Correct. I mean, those things could be happening if you're not paying attention.
Yes.
So I know we've talked about a lot of the problems that would cause platers to prematurely dump their bath. So let's recap those 5 ways that platers, 5 things that platers can do to really, be able to manage their EN plating baths a little bit better. Go ahead.
So the 5 most important ways that I feel that you can extend the bath is the number 1 is control. you need to control the parameters, the nickel hypo pH temperature. Those parameters need to be kept in control. If you don't keep those in control, you will have, if you were charting it, you'd have like a saw effect, and the bath is going all over the place. That can cause plate out. So control is number one. Number two is your rinsing. Make sure you have good rinsing coming before the bath itself. You typically want to use DI water. Some shops have DI water, RO water. Some shops don't. But the cleaner the rinses are, the less contamination you're going to bring into your bath. Probably number one, I probably should back up to, is because before you put the bath in, you actually passivate the tank itself and all of the plumbing. So with passivation, you're actually you're dissolving the nickel with a nitric acid. And on top of that, a stainless tank, you're putting a passive film on there, which stops it from plating out. If you don't have a good nitric, you will start plating out immediately. I've seen it happen many times. They'll get the call, say, hey, I put a brand new bath in. And it's plating out immediately. So make sure the nitric is good. Filtration, good filtration. You don't want to make up a bath and have an old filter on there or something where you get like these little BBs in there and you're getting played out and you're not capturing the particles. If you don't have good filtration, if you're not filtering 10 to 20 times an hour, then you're not really filtering that bath. That bath needs to be filtered.
Right. And you said not the bags. You said not the bags, but instead use the cartridges. Is that what you were saying?
Use bag filters. Bag filters is it's the easiest way. It's the easiest to change, to look in there and see what you're catching. The surface area, and typically the bag filters you want to keep out of the tank. Some tank setups have the bags inside of them. I don't like that because number one, you're taking up real estate. Number two, you're putting something in there that can plate. Anything can plate in an EM bath if it has an active spot. If you get a little bit of nickel or if you touch a piece of steel onto that bag, you're going to start plating out. And then one of the other things is idle time. And we see this a lot. When baths idle, if you say you start up a bath, it's got to be 190 degrees, all right? You've got your 6 grams per liter of nickel, 30 grams per liter of hypo. What happens is your hypo starts to break down. You build ortho. And then your stabilizers might break down a little bit. And then there's an imbalance. So then, you start to make your additions of 1-to-1. So if you had to make a gallon add of nickel, a gallon add of a hypo, as you go through the bath life, your hypo could drop and your 1-to-1 ratio is no longer there. And if you don't check your hypo as a separate test, you could run that ratio off too long and you could have premature plate out or other issues. Gotcha.
Great. All right. That was 5, right? I believe it was. That's a lot of things. Very, very helpful things.
We could go on and on.
There's many more. But again, Jason, I appreciate you joining us today on Seen and Solved, and appreciate you out there helping the platers of America fix all these problems.
Cool. Thank you.
Seen and Solved is brought to you by Hubbard-Hall. Better results, less chemistry. For more podcasts, go to hubbardhall.com or wherever you get your podcasts.